Yep. 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 You're absolutely right. I got no mosquitoes trapped in it, but I got a whole lot of other bugs. And I think it's still in the garage. But yeah, because my wife, they really like her. They don't really bother me too much, but she can't go outside at night. She can't go outside in the garden in the morning. It has to be full sunlight, and it's just sort of a drag. So Jim or James, you're going to flip slides?
Yeah. Do I have
Yep.
share screening capabilities, or Rob, can I have that? And I'm going to be his slide master.
I don't trust that with this machine.
Yeah, no worries.
All set.
Okay, thanks, Rob. Let me see if I can do this right. And let's see, there's your slide. And now to share.
All settled back, Rob, from your trip down south?
Yeah.
Cool.
Yeah, it was a good trip.
Good. I heard you on one of the parks, but I didn't think it was you because the gentleman that was QSOing with you, I think, said you were from the Dakotas. And it's like, that can't be Rob. And then I found out a day or so later, I guess it was you, and the guy got your location wrong.
That was because I think I posted the wrong number. I was
Yeah.
a digit off or something like that.
Yeah, my ears are not as good as they used to be either. I mean, I heard somebody, I don't know who they are. They're from Meriden, perhaps husband and wife, or maybe dad and daughter. I'm not sure, but they were using Echolink, and I really couldn't hear her call sign because she wasn't using phonetics, and it was like TOP. I couldn't make it out if it was a TOD, TOP, TOZ.
Yeah, that sounds familiar.
And it's like I had to go on the Echolink server and go look at the history and find out what her call sign was. So yeah, did work some CW today on Parks on the Air. I didn't work Dave CW, but another guy, I think he was from Tennessee, heard him, so chimed in on him. Got to get the cool. CW back in action. Oh, what time is it? 7:27. And I know I've talked to a few people, but retirement's good. It's good.
You're looking good, Steve. I hadn't seen the beard before. That's a good look for you.
Yeah, it's I haven't shaved since October last year, so
congrats.
No shave and no haircut since July of last year, so I'm just gonna see how bad it gets before my family disowns me.
Yeah, no shave 19.
Yeah. Hey, keep it pulled back and straight on looks. People can't really see the ponytail, but it worked pretty good while I was still working. And my boss said, "You got a ponytail?" Because everybody was virtually, and I said, "Yep, got a problem with that." Yeah.
I think I might have found the problem with that FT100. I had the covers go on there. It's clamshell type cover, and covers go on. They've got these copper tape on it that makes contact with the chassis and the cover. And I pulled it off. I started looking for dry capacitors, and when I couldn't find anything, I saw that all the mods had been done. I thought, what's going on? I bought a new mic for it. That didn't help. And I looked at the cover again, getting ready to put the cover, and I realized that there was some corrosion on the copper. I ran a meter across it just dragging a meter across, hit the corroded part, and the resistance went way up to 1,000 ohms or better. And I thought, well, if nothing else, I know active corrosion can introduce noise. So I replaced all of the copper tape on it. I just haven't had a chance to connect it up to an antenna or dummy load and see what happens.
Now, an FT100, is that an HF rig only?
Yeah, it's 6 through 160.
Yeah.
That's actually 2 meter 440, 6 through 160.
Oh, how old is that radio?
She's an oldie. She's probably 90s something.
Yeah, late 90s on that one.
Huh.
You couldn't just clean up the tape?
Brand new.
Clean up the what, John?
Clean up the tape.
No, it was easier just to replace it. I have tape.
No.
It's almost the same age as my Kenwood.
2000, right?
Yeah, the 2000, I
Yeah.
think was around that time frame.
It's a very compact rig. So we'll see.
Yeah,
Yeah.
I was looking at Harold Kramer's 7100 the other day down at Wharton Brook. That's a compact rig. That's really tiny. All right. What do you think, James? Should I kick this off or?
Yeah, whenever you're ready. Can you see my screen? Is
I
my
can-
screen?
I can see the screen.
You
So,
see the title screen. So just beep or tell me slide or whatever, and I'll flip
Yep.
it for you.
yeah.
And otherwise, take it away. So Steve is presenting tonight on the semiconductor threat. It's a
Yeah.
fascinating presentation, and I'll just pass it over to Steve. Take it.
I can't see everybody that's on, but I think I know most everybody, but just give you a little background on myself. First of all, I'll go through this first slide. So if anybody really wants to know what those two wafer looking things are, that's exactly what they are up in the upper right-hand corner. And then the center right, or I should say left corner and the left center, those are 12-inch wafers. I think they're 200 millimeter. I think that's right, or maybe 300 millimeter, whatever that translates to. But those are big wafers. I'm not sure where I got those. I think the top left corner, that might be Micron, and the middle left, that might be Intel. But each one of those block looking things in that wafer, that's actually an IC or integrated circuit. So what they'll do after that wafer is completed, and those are completed, they slice and dice them, they call it. And that's basically, they take a laser cutting tool that slices all those ICs into individual parts and then break them apart. And then they package them up, usually in nitrogen, and they send them off for packaging. And that packaging is usually done in Malaysia, Singapore, basically the Southeast Asia. And which brings me to the Corona pandemic tie-in and why the semiconductor industry is in such disarray, because all the testing and packaging is pretty much done in areas of the world that have a very, very big impact on the pandemic. And so the workforce, the fabs and the slicing and dicing and the packaging, those things usually run 24/7, 3 shifts a day. They never shut down. And when the workforce gets sick, they have to run skeleton shifts, and sometimes they eliminate a shift, and sometimes they eliminate completely the entire fabrication. So that's why there's such a parts shortage in the semiconductor world. Up there in the right-hand corner, that is an Intel fab. Those are actual Intel workers at a fab. It looks like they're having a business meeting, but they're actually probably prepping for today's work. And they have to wear those things the whole time that they're in that facility. The facility is a positive air pressure. So, basically there's no particulate matter inside that place. And it gets very warm. I know a couple of people that worked in fabs. I have a friend that works at a fab down in Texas right now. She's a supervisor and is very uncomfortable living in those bunny suits. And in the center right of the screen are some more, I'm not sure who those guys are, but what fab that is, but that's what you do in a fab. You stand on your feet and you're operating machinery, and it's a pretty boring job, but it pays really well. 10 years ago, easily 6 figures. And generally as a 2-year degree to get in there. Actually, my friend that works at the fab down in Texas is just a high school grad, but she just worked her way up. Next slide, James.
Certainly.
Can they automate those functions?
Yeah, so you're absolutely right. Some of the functions are automated. I got to go to a Micron's fab out in Idaho about 10 years ago, 8 years ago. And basically when they move those die, so I should say the wafers, when they move the wafers from one work cell to another work cell, that's all done by robotics, and it's all above you. They're like 20 feet in the air above you, and it just goes to the next workstation, whatever process that has to get done. And by the way, that wafer that you saw, that takes between 12 to 16 weeks to grow. So they grow those wafers. So the blank wafers come from fabrication facilities, and then it's brought to the fabs, and they epitaxially grow stuff out of I forgot what they call that blank. I call it a blank, but there's actually a like plug or something like that they call it. So anyways, most of you guys know who I am, but I just thought I'd throw this up there in case, not everybody knows who I am. So I'm Casey Wanese, grew up in Western Massachusetts, settled in Connecticut in 1980. That's right. Wow. I've resided in Wallingford since 82. I got my tech license in 14, extra license in 14. I did a call change in 16. Graduated from Purdue in 1980. 15 years designing motor controls, communication equipment, and sound gear. 26 years as an application engineer in the semiconductor industry, and I retired July 2nd. So
Woohoo.
I am done. I'm done. I am so glad I'm not working anymore. Anyways, so semiconductors have become a scarce commodity, which recently have been driving the up cost of goods. I think Wise cameras, if anybody has a Wise camera, I have one. I bought mine for $20 about a year ago, and now they're $34. And they did a bait and switch. They basically said we redesigned it. They really didn't. They just renamed it, and they put it in a waterproof housing instead of being in a non-waterproof housing. And now they charge $14 more. And that's because the cost of silicon is going up. So I thought I'd give an industry perspective on how it could affect you. And I put this last bullet in there after, I guess, field day, because something happened to one of the rigs. The finals went. And I guess, the club is very fortunate that it happened to one of the older rigs. If it happened to the 991, that's a relatively newer rig. I'm not sure you'd be able to get the finals. You'd probably be on a long waiting list. Luckily, that older rig probably had finals that were not in high demand, and therefore there was excess inventory kicking around someplace. So basically what I'm telling you is don't go breaking anything that has electronics in it, or otherwise you could have a long wait for getting a replacement. Next slide.
Mm-hmm.
Okay, so just some data points, and I found some of these interesting. So, if you go back 30 years ago, if you go back to 1980 when I graduated, 41 years ago, the United States really had a very, very big share of the semiconductor market. We made a lot of chips here in the US. Over the last 40 years or so, everybody wants cheaper things. They don't want to spend $4,000 on a cell phone. So what happens, how do you get the cost of goods? How do you get the cost out of goods in semiconductor world is you basically build stuff in places that people don't make a lot of money. So Taiwan now produces 20% of the world's semiconductor products, and over 90% of the high tech chips. So like all your Intel, i7s, i9s, i5s, i3s, that's not made here. It's all made in Taiwan. at TSMC, not even a US owned fab. Asia as a whole produces about 3/4 of the global semiconductors, where the United States only manufactures about 13% today. Hundreds of
Steve?
companies. Yep.
Hey, I was watching a show a few weeks ago about semiconductors. And they said that Taiwan makes the most sophisticated chips because the US can't make them. They don't have the capability that Taiwan has or the expertise.
We don't, it's not the expertise. We don't have the fabs. So the fabs that TSMC and SMC haven't, by the way, SMC is one of the bigger fabs in China, but right now, no US company can use SMC, part of the Donald Trump thing. And, you know, it's very political. But we can't use SMC to build any chips, but we can use TSMC. TSMC has, and I might get this wrong, I think they have a 3 nanometer process, maybe it's 4 nanometer process. And that is the size of that's the size of a trace, if you want to call it. Think of it as a circuit board. So they can have a 3 nanometer trace on that circuit board. It's not a circuit board, it's a piece of glass, but they have the smallest geometry. So they've invested, and I have a couple of bullet points on that. They've invested, they being Taiwan and China, the Southeast Asia guys, they've invested millions and millions of dollars building these fabs to build these parts. Where does the actual designs come from? A lot of it comes from US companies. You know, NXP, well, that's not really a US company. It used to be Motorola, but NXP, Intel, Xilinx, AMD, all the designs come from, a lot of designs come from US companies, but we don't have the fabs here in the US to build them, so they go overseas. The problem is China is flexing its muscles. So if China seizes Taiwan, basically the whole world is going to be in turmoil. You're not going to be able to get parts, period, because that's where everything is made. So anyways, we'll get more into that. So we only produce about 13% of the parts in the US. And those parts that we make are generally pretty low tech parts. Some fabs, 6-inch and 8-inch wafer fabs are still going on in the United States, like in Texas. But you know, that's not building the most sophisticated parts. That's not building your Intel parts. It's not building your memory parts. So hundreds of companies that design computer chips, no fewer than 24 globally that manufacture them in large quantities. So you've got hundreds and hundreds of companies designing things, like designing chips, but only, you know, 20 or so fabs worldwide make them. Global Foundries, which I lost track of these guys when I was doing the research on this. Global Foundries is a solely owned subsidiary or solely owned government company of Abu Dhabi. So again, you know, not the US, Middle East. Their Malta plant runs 24 hours a day, pumping out 500,000, 500,000 intricate silicon wafers a year. Those are the wafers. And out of the wafers, you may get between 500 to 2,000 chips out of each one of them every day. There are about 700 processing steps along the way to making a wafer.
I suppose they need us though, because we're the ones consuming.
We're designing it. It is a symbiotic relationship, I guess. But there are a lot of Chinese companies that are making really good processors today. They aren't in PCs yet, but you're going to see in the next 10 years a big shift in, unless the US does something, and I think they are. So there's a lot of steps in making a chip. There's about 700 steps in making a wafer alone, through dozens of layers, and patterns are printed on and etched on the top of this piece of glass. And it takes, like I said before, 10 to 12 weeks to grow one of these things. And it takes an additional 4 weeks to package it. And that includes slicing and dicing, sending it over to Southeast Asia, having them put the leads on it, package it up, and then test it. That's another, 4 weeks. So you're looking at anywhere from 14 to 16 weeks. So if, Rob is sort of in the business where he has to buy parts where he works. So if you call up, DigiKey, or you call up somebody and say, hey, I need this part, and they say it's a 24-week lead time, that means they haven't even started making them yet. So they haven't even grown them. So that's the problem that we're in. Analog Devices, which some of you guys may know who they are, they make DSPs and they make A to Ds and D to As and regulators and things like that. Right now, their typical, and this changed within the last 6 weeks, their typical lead time now is 60 weeks. So it's going to be tough. So Connecticut, which probably not everybody knows, Connecticut is home to, at least that I know of, 2 companies that manufacture the parts that make the lithography equipment to make the wafers. One of them is in Middlefield, and that's Zygo. I'm not sure if anybody have ever heard of them. It's an interesting company, but they make interferometers, measures really, really small distances. And then down in Norwalk is ASML, and I don't think that's a US company. I think that's a German company, but they have a huge facility. It's the whole Perkin-Elmer. Yeah, it's the whole Perkin-Elmer. Pardon?
I'm sorry. Yeah, I'm familiar with both of those companies.
Yep. Yeah. I think Perkin-Elmer, going back 35, 40 years ago, was ASML. Perkin-Elmer sold the divisions off and it became something else. And then finally ASML swallowed them up. So if you're ever down on Route 7 in Norwalk, you'll see all these buildings, ASML. They make stuff that does that goes into the manufacturing of the wafers. So 2022, we'll see 29 new fabs built. So next year, it's on scheduled that there's going to be 29 new fabs built. China and Taiwan will be building 16 of these. The US will build 6, and Europe 3, and Japan and Korea each 2. So you can still see that China and Taiwan are investing heavily, and the US is, maybe we'll wait and see. So I still don't think the US has got money in the game. They really need to do this. It should be government. It should be government sanctioned, because it's us. This is a U.S. industry that we allowed to go overseas because of cost. In 1990, the U.S. manufactured 33% of the world's chips. Intel, I'm not sure if everybody knew what that stood for, but Intel stands for Integrated Electronics. And Intel is a manufacturer. They are not really an innovator, because once something becomes a commodity, Intel doesn't make it anymore. That's why they get into businesses and then they get back out of them. Like they were one of the first companies to make flash memory. But once flash memory became a commodity, they said, no, we're not doing this anymore because we can't make money. They're still a big player in the processor node, but they're slowly seeing their captive market slipping away because there's other ways to do processing that Intel can't make money at anymore. So we'll see another 5-10 years, maybe Intel's gonna maybe not make processors anymore. So they've committed to build 2 factories in Arizona, and it's going to cost them $20 billion. A fab today is between $6 to $10 billion to make. So they can see why the United States companies are a little slow to, build fabs. So a lot of money. So right now, Samsung and TSMC have the most advanced process node smallness. I think it's either 3 or 4 nanometers. It's pretty small. It's only a few hundred atoms wide when you think of it in atoms. And today, this is, when you look at your car, I said this to somebody the other day, when you look at your car and you think there's only a few processors in there or whatever, there's over 1,400 integrated circuits in a typical car today. And they're everything from your switches on your doors to your door locks, to your fan for your heating and cooling, to your water pump, to your temperature sensors. I mean, there's hundreds and hundreds of integrated circuits in your car today. And so now you're wondering, if you ever wondered why Ford and GM and a few other manufacturers basically don't have any cars on the lot, this is why they can't get their chips. So I got this from a friend that I'm still talking to at my previous company. Most recent update, July 28th, semiconductor shortage will not correct itself until 2023. So that's what that they're telling customers, and customers like Wheelan or Honeywell or Zygo or ASML call up to buy parts, we basically tell them, get your parts on order today, because if you don't have them on order, you're not even going to get in line to get parts. Next slide, James.
Steve, can I ask you a real quick question
Sure.
at this point?
Yep.
So what is driving the shortage? Is it a shortage of silicon, or is it just such an increased demand for
So
the chips?
it's a little of both. So what I think I talk about this in the slide, but what happened in 2019? There was there it is. Okay, I got it here.
Sorry,
So
I didn't mean to jump ahead.
Yep.
I always hesitate asking questions because it's like
Yep.
I always ask when it comes up on the next slide.
So typical lead time for semiconductors, as I said before, is 12 to 26 weeks.
Mhm.
So when you break it down, this is how, where you grow it, you package it, you test it, you transit, logistics and management. So anywhere from 12 to 26 weeks. So what happened in 2019? There was a downtick. So a lot of fabs said, okay, planning for 2020, they said, we're not going to do much. And then 2020 hit, and there was a slight uptick in 2020, except for the automotive industry. So the fabs said, we're not going to expand. We're not going to build more fabs. We're just going to wade through this. And then after the pandemic sort of started.
A little bit. Thank you.
So after the pandemic got a little better, and businesses were opening and people were spending money and people wanted to buy cars, all of a sudden there was a big uptick in cars. The other thing that drove the big uptick was people working from home. So all of a sudden, people working from home, oh my God, I need a laptop. Oh my God, I need a better router. Oh my God, I need this. Oh, I need a new cell phone. And so the silicon demand went way up, and the pandemic hit Southeast Asia. In one case, I don't know if I've got the statistic in here, but NXP actually is the old Motorola. If anybody remembers Signetics or Philips Electronics or Motorola, the bat wings that made chips.
All of the above.
Those guys are now called NXP, which stands for Next Experience. That happened, I don't know, 8-9 years ago. They actually, in their fab in China, they shut it down. So they didn't make any parts. And then I'll talk a little bit more about other calamities that affected the semi industry. So the pandemic struck, affected all but growing. So basically the packaging, testing, transit, and logistics got really screwed up. So the only thing that really didn't get really too badly affected was actually the grow and the stuff. You're growing your plants, if you want to call it that.
But it was both. It was the pandemic hit both the supply and the demand side. People needed more technology, more tech, more appliances that need silicon chips, and at the same time, the factories and the distribution chain that create and market these chips were shut down because of the pandemic. So it's like a perfect storm almost.
Yeah, and that's exactly what happened. I mean, the packaging is all plastic for the most part, unless you're buying military parts, then they're ceramic sometimes. Most everybody has switched to plastics, but there was a plastic manufacturer, Louisiana, someplace down south. They actually had a fire, and they produced, like, I'm going to say, half the world's plastic for semiconductors. And so, like, that's another thing that hit us. So anyways, you got, here it is right here, fires. Plastic producer for device packages, AKM in November 20, and Renesas. Now Renesas, if anybody knows Hitachi Semiconductor, so they are now called Renesas, or Renesas, however you want to pronounce it. So they had two major fires that put them out of commission. There was a powder outage at TSMC's, that's over in Taiwan, Fab 6. They lost 12 weeks of work. They were growing the parts, right? And then they had a power outage. And when you're in the middle of growing stuff and you have a power outage, there's not enough backup power to keep the plant running. And so they lost 12 weeks of work. And that affected TSMC is a fab, they're like a manufacturer. So that affected so many people, Intel, NXP, Xilinx, everybody that uses them as a manufacturer was affected. NXP, they lost 12 weeks during a fab problem that they had down in Texas. That was, remember that Texas had the coal, was it the coal snap?
And then they had a flood afterwards, right? Like
right.
Yeah.
I have a friend that lives in Dallas, and he was standing on his in-ground pool. It was it was frozen solid, and I guess what happened was, nothing down there is really insulated. Water pipes froze at the fab, burst, and wrecked everything in work in process. So that was at NXP. Cypress and Infineon were in the same boat. They're down in Texas. That's where my high school friend works. She works at Cypress/Infineon, and they make memory chips down there. And all the flash memory that they were making was all thrown away. They had to start over. And it's not only starting over, you got to clean the place, you got to fix it, and then you got to start making again. So they lost like a half a year's worth of work, if you think about it that way. So, what's going to happen, the fear is that the semiconductor industry is trying to keep everybody happy. From places like where Dave Tipping works at Honeywell, they make, Firelight, they make fire alarm systems, fire alarm panels. So we're trying to keep people like them happy. We're trying to keep people like Whelen happy. They make the light bars that go on top of ambulances and fire trucks and police cars. They're trying to keep medical places like Covidien down in North Haven happy, that buys electronics for their staplers. They're trying to keep everybody happy. And the biggest consumer is the auto industry. So the auto industry is taking it on the heels a little bit. So there's some lobbying going on. There was, at least in June, by automakers to have government step in and say, hey, semiconductor manufacturer, car manufacturers get first dibs, which is really bad. So hopefully that doesn't happen. There was a little talk about it in May and June. I haven't seen anything come about that. So we'll see. Interesting. There's I didn't put the name down. Wolfspeed. So has anybody ever heard of silicon carbide?
Yes,
Okay.
sir.
Yeah.
So silicon carbide is an up and coming high frequency, high power type of MOSFET. And right now, Wolfspeed, which used to be part of Cree, Cree basically spun off. They're owned by a Chinese company now, and Wolfspeed is now the old, if you want to call it, Cree. They're based in South Carolina. They're actually building a fab in upstate New York, and that's an artist rendition of the fab. It should be done next year. And they sell the bowls, that's what they're called, the blanks. They sell the silicon carbide blanks to people like Infineon, ST, themselves, and a few other manufacturers that make these MOSFETs. Typically really good for high frequency switching applications. And we'll talk a little bit about ham now. What's the great thing about switching at higher frequencies? Come on, this is a quiz. The magnetics get really small. So you can have a power supply that is a kilowatt power supply switching at 5 megahertz, and the magnetics will be real small. So weight will be real small, cost will be small. So that's the big push in the next 5 years, 5 to 10 years, is silicon carbide for high power electronics. Next slide.
Steve, I got a question for you. Move on.
Sure.
You got any input on government contracts for their electronic devices? I know they're heavily investing on some of the industry that serves government. Does a lot of investing in software-defined radio for not just communications, but a lot of their other systems like radar and fire control and things like that. How does that, you got any input on how that factors into this?
So the two manufacturers that are heavily invested into SDR, software-defined radios, are Xilinx and Intel. And Intel, it was the old Altera. So remember a couple of years ago, I gave a talk on FPGAs, field programmable gate arrays. So the reason why there's those two companies are heavily invested in the SDR is because they can be reconfigured on the fly, and you're not putting together a software-defined radio that does this only. It can do this. It can do a lot. And so those two companies are geared up to, I guess you'd say, really clean the market up, maybe. The problem with using an FPGA from Xilinx or from Intel, and by the way, Xilinx is going to be soon bought by AMD. So it's going to be AMD and Intel again, fighting over this market. And they, to do a software-defined radio with those two types of products takes a long time. It's 2x the development cycle than using a DSP from TI or from Analog Devices. But that's the competing architectures. You're either going to be using a DSP, a real DSP for software DSP, or you're going to be using hardware, meaning FPGAs, to do that same function just in hardware. There's great relationships being built now with Intel and AMD with people doing software-defined radios. Guys on Long Island, Telephonics, they're doing software-defined radios. I was actually supporting a customer in Manhattan doing software-defined radio. They were called Persistent Systems, and they did a X-band. Can't remember. It was like X-band, almost like cell phone communication, but it was a handy-talkie that talked to point, and that used an FPGA, and it used an NXP processor to do that. Does that sort of answer your question, Rob?
It kind of alludes into it. I've got another question from Sean KC1NQE on the chat. Steve, any knowledge on photonic and optoelectronic integrated circuits? Do you see silicon going obsolete in the near future?
Not in the near future, because they got to figure out, and that's a good topic. We're probably 30 years away from that, in my opinion. The fabs today cost this much money to do for silicon. I just can't imagine what the fabs would cost for doing photonic calculations. I think the next biggest leap in processing, if you want to call it that, is quantum computers. And we have a company in Connecticut that is doing quantum computer research. They're spin-off of Yale. They're down in New Haven. And when you think about quantum computers, I think they're building a 128-bit machine, but a quantum computer can actually crack AES encryption in like 2 seconds. And right now, AES, whatever it is, 1024, can't be cracked. So the calculation speed is so much quicker. That comes with a whole nother set of problems, and that is everything's got to be nitrogen cooled, and the machine is huge. It's the size of a house. But that's what computers were back in the 40s, right? They were the size of a house, and then they became the size of your laptop. So, I don't know if we'll be around when it happens, but it would be interesting. So my opinion, I don't think optical or photonic type processing calculation power is going to happen for a long time. Anyways, so this is a little bit about lithography. Oh, it's 3 nanometer. I told you I got it wrong. So they have a 3 nanometer MOSFET technology, TSMC and Samsung. And there it is, 30 atoms. So when you think about a trace on a PC board, think of it only being 30 atoms wide. So how do they do that? I think aliens gave us this technology, in my opinion, but who knows? So the interesting thing about what's driving the lithography is memory. So your DDR4, DDR5, everybody, DDR2 is sort of like dead. DDR3 was short-lived. DDR4 is what you see in most PCs today. DDR5 is on the horizon. That is all driving the lithography to make it smaller and smaller, because people want more and more memory, and you don't want a chip this big in your PC. So you want something nice and small. So that's what's driving the lithography shrink. And the more parts you get on a wafer, the more money you can make. So just to put it in perspective, your 7th generation Intel i7 processor is 14 nanometers. So they're building parts now that are I got, that was a typo up there where I got 3 micrometers is 80, 30 is 3 nanometers. So the Intel i7 is 5 times bigger than the smallest processing technology we have right now. And we're just starting to see i7s now. When you look at RF power transistors, typically you see them at 45 nanometers. So power transistors is stuff that we see in the output stage of our HF rigs or, UHF, VHF rigs are not the driving force behind this technology. They're 45 nanometers. They're really big. Wafers are generally 8 or 12 inch in diameter. Older 6-inch fabs are still, there's a couple around, but most of them are closed. And that chart down there sort of shows you the number of dice you can get per wafer. So if you've got, a die size that's 200, millimeters square, you can get on a 300 nanometer wafer, that's a 300 millimeter wafer, that's a 12-inch wafer. You can get, close to, 1,000 or 2,000 chips. And if you're selling each one of those chips, like an i7, let's say you're selling it for $200, do the math, you make a lot of money. That little pie chart over on the other side there, that sort of shows who the big player is. Samsung's the biggest, TSMC is, I think, followed by next. Is that right? No, actually, Intel's next. Hynix is a DRAM producer, and then TSMC is the 4th largest. Texas Instruments big, but they're getting smaller. And then this chart over on the right-hand side sort of shows you where the nodes are. I graduated from college in 1980, so we were talking like 1.5 micrometers, which is pretty big. And here we are, 40 years later, we're talking 3 nanometers. So pretty small stuff. That little diagram up there in the top, I don't know what that is. It might be a transistor, but we had to do that back in 78. I think it was 2nd year electronics class. We actually had to make a class A/B amplifier, I think it was. Then we had to take the transistors we used for that and put it into basically a chip. And then we went down to us in Worcester. I think they're still there. I forgot who it was at the time. Sprague. Sprague had a fab down there in 1978. We went down there and they looked at our hand-drawn stuff and they said, yeah, we could make this. So I don't know if they were just being nice or whatever, but it was sort of interesting. Anyways, next slide. Okay, so the enormous cost, I sort of hit on this already. So the one thing I didn't talk about before is all this money it costs to make a fab. So like Intel, I said, is going to build 2 fabs for $20 billion. So they're going to build 6 fabs, whatever it was. They're going to build some fabs for $20 billion. They're going to be able to use those for 5 to 7 years. So it's a really bad investment. So you spend all this time and money and you buy the land and you do all this stuff to build a fab that you're only going to be used for 5 to 7 years. Then hopefully, if you're lucky, you'll be able to sell that fab to somebody else who wants to build older technology parts. So when they build a fab, like right now, the stuff that TSMC has, 3 nanometer fab that they're building, in 5 or 7 years, that's going to be old technology. And probably the only people that would want to build anything on that were people that would be building power transistors, if they were building on that. So that's the big problem with the enormous cost of building chips. And I didn't even talk about the environmental concern. That's another whole issue.
Hey, Steve?
Yeah.
Why is that they're only good for 5 to 7 years?
Because when they build a fab, they build it for a node. So they're building the ones right now for 3 nanometer. In 5 years time from now, that's not going to be state of the art. The people are going to figure out how to make the geometry smaller. So they'll have to build 1.5 micrometer, and you can't build 1.5 nanometer on a 3 nanometer fab. So you basically have to build another fab for 1.5 nanometer. And then you start building all the latest and greatest stuff on the 1.5 nanometer stuff, and the 3 nanometer stuff eventually tails off and people stop buying it. And then they figure, okay, we're not making any money using this fab anymore. We need to dump it. So that's what Intel's been doing for years. They build for 5 to 7 years on it, and then they dump it to somebody else, Philips or now NXP or whoever, to build other stuff on it. It's quite a waste.
They can't just replace the machinery?
No, I've asked that, and they said it's too much cost to retrofit. It's cheaper to build from scratch. And it's like,
Wow.
okay, yeah, it's our way of life, I guess. Throw it away, start over. What's even more interesting is New Mexico had a fab. Philips had it, and I know this one because Philips sold this technology part. It was a CPLD thing. Don't have to go into that, but Xilinx ended up buying that fab. That fab used 1.5 billion gallons of water a day. It's like it was crazy amount of water that the fab used. And then when you look at people like Intel had a fab up in Washington. It was on a 4 or 6 inch. It was really old. They built, here we go, I'm showing my age, 8051s. Everybody knows what an 8051 is, right? So they built 8051s up there in Oregon. And then finally the fines got so high from the EPA because they were using chemicals that were really bad for us, that they stopped paying the fines, and they said they're just going to shut the fab down because they just couldn't make money anymore. So let alone the cost of building this stuff, the chemicals and the water that these fabs use are not good for the planet. Also that we can get, an $1,100 iPhone. So anyways,
Steve,
yep.
Three questions I have for you. You can maybe cover them now, or maybe you're going to get to them. What does FAB stand for?
Oh, a fabrication.
Okay. So that's the whole thing, the machinery and the plant.
Yeah. So I've never been in a fab because you got to be in a bunny suit and all that stuff. But the pictures that I've seen, it's basically, that's where they grow the wafer. They usually get the bowl from another manufacturer. In this case, I'll talk about silicon carbide from Wolfspeed. Wolfspeed would sell a bowl to ST Micro, let's say, to make some FETs. They would get that, and then they would take their photolithography that basically represents the layers, and typical layers on a chip might range from 20 to 50 layers. So think of it as a multi-layer PC board. It's just not a PC board, it's glass. And they basically shine light through this photo mask. They shine light. It's not, I think it's UV light now. It used to be regular light, but now it's UV light, shorter wavelength. And eventually it'll be X-rays when they get really small. That goes on to the stuff that they grew on the wafer that is photosensitive. And then after they you want to expose it to the light, then they wash it with a chemical, usually a type of acid, that etches away the stuff that wasn't or was exposed, and that leaves part of a transistor. And then they take and they grow some more stuff on top of that, and then they do the same process again, shine the light through, and then they'll etch through that. And that's why it takes so long to build these chips. And that's what they do in the fab. They do all this layering and photolithography stuff.
And you mentioned that you said a bowl of what, silicon?
I forgot the actual name. I think it's called bowl, and it's basically a piece of silicon or whatever the material may be, gallium arsenide it might be, and then they take and they slice that, and then that's what they grow their material on.
And when you say grow, I'm not thinking they're water and stuff. What are they growing?
So they take gases, and they take elements, and they gaseousize them and put them in the chamber, and over time crystals grow. And
Holy cow.
the crystals grow to a few nanometers high, or maybe even smaller. Maybe it's 1 nanometer high. And then okay, we've got enough for this process. Let's start photolithographying it. And then they etch that away and they do the same thing many times over.
Okay, my final question is, so you were an electronics engineer. You're a company, my company, and I say, Steve, design a new MOSFET or something. So you're gonna go, I mean, you have a CAD program or something and you start putting stuff together and then send these companies it by file, a computer file, and they turn it into lithography or something, or?
So somehow I'm gonna listen to you on my speakers because my headphone just got all messed up.
Okay.
So yeah, you're absolutely right. They're going to use something like Mentor Graphics with a chip design package that they're going to use, and it'll have libraries in it. So like if you're designing with TSMC would then take and give you, the designer, a library that would have all their symbols that you would use to make the picture of what you're trying to make for the integrated circuit. A transistor would be the easiest thing, it would be a base emitter or a collector.
Yeah.
And they would give you that material and it would be the right sizes. And then after you draw it, you take and you give it back to them, and 12 to 16 weeks later, you get your part back, hopefully.
Holy cow, okay.
I'm actually going to unplug my headphone for a second and plug it back in. For some reason, it got a little goofy. Let's see.
Hey, Steve.
Hang
Hey,
on.
Steve.
1 second.
Okay.
Microphone. Can you hear me okay?
Yeah.
Yep.
Oh, cool.
Hey,
All
Steve.
right. I'm not sure if I got my speakers on my headset or not. Let's see. Speaker wants to be right here. All right. Let me hear somebody. Can I hear somebody?
No
Oh,
one's
cool.
had any question.
Everybody's okay. Good.
Fun meter banana.
Hey, Steve, had a comment?
Yep.
Not working too good.
Go ahead, Jim. Can you guys hear me?
Yeah.
Yeah, but your video is frozen.
His internet is not holding up.
That's probably my PC. It's probably my PC more than my internet. But go ahead.
I had a comment, Steve, you talking to me? So,
Yeah, go ahead, Jim.
Jim, go
oh,
ahead.
anyway, well, you mentioned bowl. So I did some Googling. It's BOULE. And it says a bowl is a single crystal ingot produced by synthetic means. So it's a single crystal ingot.
Really?
Okay.
I don't know how big they are.
Yeah, I like I said, I've never been in a fab. I've seen pictures. I never actually got a wafer. I always want a wafer, but every time I asked for one, they said, "Go away, and you bother us." That's like
You're not doing good, Steve.
Yeah, Steve, your audio is falling apart.
Yeah.
stop the video.
You got a laptop cooler? You got to put that park your laptop on a laptop cooler, buddy.
Blow on it.
Yeah, well,
Somewhere in there.
let's do this. All right, let's start this. All right, so I got the cooler on, and I turned off my video. And is that any better?
A little bit, yeah.
It's marginally better. Yes, Steve.
What else do I have running? Anything? Kill this. I always have problems with Zoom after about a half hour running. That tends to slow down.
But you seem to be
close.
recovering. You're on the road to mending, Steve, so
Do I
that sounds
sound
good.
fine?
Yeah, it's a little scratchy, but you're better than you were about
Okay.
2 minutes ago.
Okay. Yep. All right, next slide, James.
Slide change, Jim. There we go.
All right. So
Sorry about that.
Yep, this is what I was talking about before with the pandemic. So in 2018 we had growth. 2019 we had shrinkage in the semiconductor sales growth, and then in 2020, in the middle of the pandemic, we had growth based on 2019, but we were still down from 2018. So when you look at minus 12 plus 6, we're still down 6% from 2018, and then 2021 they expect huge growth. And we're seeing that, and I think the huge growth in the semiconductor sales is stemming from the point that people are really scared they're not going to get their parts, so they're over ordering. So I think in 2022 you're going to see a sales shrink again, and that really drives the planners crazy on did they build a fab or not. So and this trend, the shrinkage, the growth, that is what's driving a shortage. And the shortage is being driven primarily in the consumer side of things, laptops, cameras, and ISPs. Basically all your internet service providers had to upgrade their equipment because now everybody's working from home. So, Verizon and Comcast and Cox and all those people had to invest in more servers on their end. So that's what really making a shortfall of semiconductors this disaster. And then everybody forgets about 5G. 5G, now what is it? Verizon's going to give you a free phone if you sign up for 5G. And that's driving costs up a lot too. I mean, not costs, but the shrinkage. This drives the shrinkage up. So I put the Microsoft Teams over there because everybody's working with Teams now, and 5G is a big thing. So next slide.
Oops, sorry. Hold on.
Nope, too many. No problem.
Hey, Steve,
That's why-
comment while
that's
we're
what-
changing.
Yep, go ahead.
I get these emails or letters, and from AT&T is my cell phone carrier. They're going to switch to 5G in February, and they're saying my old 3G phone will not work, which means I got to buy a new phone. So does my wife, and so does my son, and I'm wondering how much demand on purchasing cell phones that's going to affect. Of course, not everybody has the less powerful cell phone like I do, but
It's definitely driving the trends. I mean, some of the parts that are in like Samsung Android phones, the higher end phones, they can't get the parts to make them. So I know when I left my last company, the guy that came in to take my position, he had worked there before. He had a phone before, but it was pretty old. He said, "I'm just going to get another phone." I don't know if he got it yet. And it was Verizon was the carrier, and it was a Samsung. I don't. S21 or something like that. But they're on back order because they just can't make them. So it's a mess. And where does this all leave us? And I put up this Avnet Arrow thing. So I don't know if everybody really knows the whole distribution network and what it is for how you get chips, but the suppliers of the world, the Intels, the AMDs, the NXPs, the ST Micros. I'm trying to throw names out there you guys may remember or know. Micron. All those people do not want direct customers, because with direct customers they have to be the bank. So they basically sell the guy the parts, and then they got to wait for payment to come back. So a long time ago, the manufacturers said, many manufacturers said, we don't want any direct customers. And for the most part, you know, those guys that I mentioned really don't have any direct customers. No, Intel probably has Dell. And AMD probably has Dell. For the most part, everything goes through distribution. And there's basically two big distributors in the world, Avnet and Arrow. They make up probably 80% of the business that goes through all the semiconductor manufacturers. So you can see North American sales in millions of dollars is a lot of money. In Connecticut, it's about 120 to 150 $1 million of semiconductor content in the state. And that's broken up into Avnet, Arrow, and Future Electronics. Those are the guys that basically do all that business. The smaller guys, the catalog guys, I'll call them DigiKey, Mauser, Newark, TTI, they're very useful distributors because their model is not to service the huge customers like GM or Whelen or Honeywell. Their goal is to service the smaller guy, the guy that's going to buy 1,000 parts a year, 500 parts a year. And so they do a very good job on that. I've bought things from DigiKey because they come in a day. You order a day later, you get parts. But they're a really good distributor, and they're a catalog house. Avnet and Arrow are more geared toward working with very, very big manufacturers. Sometimes when I needed samples, I'd just go to DigiKey. I couldn't even get samples from my company because it was just too much of a pain in the ass. So contracting and expanding sales numbers drive manufacturers to cautiously plan for expansion. And that's what we're seeing now. That was building for the future. Typical lead times is even more than 62 weeks. So typical lead times of 28 to 62 weeks are not uncommon today. And that's going to continue throughout 2022. This is why I retired, because I sold parts, and if I can't sell any parts, I can't make money. So it's like I'm done. Suppliers are implementing non-cancelable, non-returnable orders on all orders. So if you order from Avnet, Arrow, and some of them, DigiKey, if you order parts and then you get them and say, I didn't need them, you try to send them back, they're not going to take them. Catalog distributors have the largest risk at the moment because the manufacturers service Arrow, Avnet, and Future first. So basically, for like Micron's a good example, Micron will build, let's say 100,000 of some DDR4 flash or DDR4 DRAM. They will give Arrow and Avnet, because Future's not franchised, they will give Avnet, Arrow 50,000 piece buckets, and the other distributors, catalog guys, they won't get any. Or if they do, then it'll be 10,000 split up between all of them. So that's the risk of the smaller catalog houses. They're going to have a tough time making it through this allocation thing that we're going through. There's going to be further consolidation, like Newark up there, Newark Electronics. They used to be a pretty good catalog house. Now they're owned by Avnet. Arrow doesn't have any catalog houses yet. I think they're cautious. My guess is they'll either buy Sega or TTI. But, I think that was the last slide. Open it up for any other questions you may have. Yeah, there you go. Any questions? I don't. Nobody's sleeping, so that's a good thing. Oh, John is.
I got nothing from the chat, Steve. Just, for me, connects a lot of dots here.
Yeah. So, the other thing.
We do have a question from Sean in the chat, actually, but we already do that.
Insider standpoint from buy. I think we did that one.
Yeah, we took care of that question.
Yeah.
Okay, sorry, a little asleep at the stick there, but Good presentation, Steve. I enjoyed it. I learned a
The
lot.
other thing, when you look at distributors to buy parts, you always want to buy from a distributor that's a franchise distributor, because if you do want to send parts back, if they aren't doing non-cancelable, non-returnable, you'll be able to take them back. But if it's a non-franchise distributor, you won't be able to send parts back. And sometimes, parts can be expensive.
Yeah, even Newark's that way
$5
these
transistor
days.
is no big deal, but if you buy a $100 processor,
Quick question, Steve.
yeah. Say that again, Mike.
Be to manufacture those products in the United States at our labor rate.
I don't think I heard you, Mike.
What would the cost be to manufacture those products in the United States with our US labor rate? Could it even be competitive?
A lot more than it is in Asia. A lot more than it is in Asia, probably 3 to 4 times. So I don't think there's any fabs in India, but a lot of designs are going to India right now because you can basically hire 6 Indian engineers, be it hardware or software, for 1 US engineer. So that's another issue. We didn't even talk about the aspects of designing parts. That's why the big threat is, in 20 years from now, will the US still be a player in the semiconductor world? People don't want to spend what it really costs to make parts. They want that $600 washing machine. They don't want to pay $3,000 for a washing machine. And that's why everything goes overseas. I mean, I don't even think any washing machines are made in the US anymore. The last ones were in Indiana, and I think they're gone. So yeah, it's not a good time to be in the semiconductor world. And that's why when Rob mentioned on field day that 2 finals were blown, that's why I put that title up there. What happens when my finals are blown? How do I get my parts? Hopefully it's not a new radio. If it's a new radio, it's going to be tough. If it's an old radio, you might be able to find old stock someplace. So
Yeah, it was in China that we got those from.
yeah. So that's all I had. Talked about 15 minutes longer than I wanted to.
Good stuff. Nice way to spend a Thursday night.
Yeah.
Thanks, Steve.
All right.
Thanks, Steve. Good
Yeah, it was
stuff.
a good presentation.
Yeah, thank you very much.
All right. Thanks, everybody. Have a nice evening. Yep. Have a nice evening.
Yeah,
Thanks,
take
Steve.
care.
Thanks, Steve.
Thank you.
Take
Very
care, buddy.
informative.
Yep. Take it
Good
easy.
job.
Yeah, thanks, everybody. John, could you do it in 2 weeks for us? Or are you ready to go with the Arduino presentation, or do you need more time? Or I also got to fit Anton. I don't know if he's in the room tonight. He's got one ready to go too. You're muted, John.
I don't see Anton in the room anymore, but he might have been.
He might.
If he's ready to go, let him do it.
Okay, yeah, I think I promised him the next one, so I could set you up for first one in September or the second in September. I'll probably take one in September. And anybody else who wants to present, always looking for content. This has been a really fun project. We've kept it going for over a year now. We've had a lot of good topics, so thanks to everybody who's contributing. But I'll reach out to Ant and I'll circle back to you, John. And
Okay.
on the line.
Yeah, I just got to sit down and start putting it together. It's kind of done in bits and pieces, and well, but I just got to put all the pieces together.
Good stuff. Great, thank you.
Okay.
Just a quick comment that this whole idea of being hard to get parts and stuff like that is kind of hitting home, because I've got a dead power supply that's going to need parts to be, to get it working again. It's older. It's from around 2001, 2002, but we'll see how this plays out.
Yeah, maybe someone will have in stock, Joe, since it's old, if they're big power output transistors.
Well, it can be 6 one, half dozen the other, because it's so damn old. There's not a whole lot of parts or spares lying around anymore. And so we'll see we'll see. Hopefully it isn't going to get too crazy. Because otherwise I'm going to have a very large, expensive boat anchor.
Yeah. John, VDF, what do you think about all this?
Yeah, I would think, Joe, I would think a lot of those things, like, if it's power transistors, that they don't change much. They just keep making the same ones week after week and month after month, and they're
Yeah,
not
it's the
yet.
age of it had me kind of concerned, but from what I'm hearing, I probably got a better chance of getting parts for that than I would for something like like an 850 or something like that.
They're probably using the same power transistors today that they were using 20 years ago.
That's a good thing.
Yeah.
All good. We ran into the car shortage. My wife's lease was up at the end of July, and we went to the dealership, and it was very surreal how few cars were available. They were actually trying to entice her into taking a lease on a service department loaner car from the prior year, setting that up as a lease, and we said no, we'll pass on that.